Okay, hopefully that wasn't too terrible. You might need to watch that again. You're gonna have to practice. This stuff is weird. Okay, it's not difficult. It's just really different. So let's go back to this concept of inverses, because the other part of this lesson is not just graphing logarithms, it's also finding their inverses and evaluating them. Okay, so here's where it's going to get weird, if it hasn't already. In the unit that in the lesson we just did last time, 12.3, we talked about how y equals e to the x. And again, that's exponential. So that is a base to an exponent equals an answer. When you write it as a logarithm, you write it as bay. Log is bay. So the base is Euler's number, e. The answer is what it equals, which is y. And that in turn equals the exponent being the x. So we didn't actually talk about log base e because we called it the natural log instead. So y equals e to the x is the exponential form, and x equals the natural log of y is the logarithmic form. If these are the same thing, just in two different ways, exponential and logarithmic, why did I just say that they were inverses? I need you to take a closer look. This is the natural log of y, and it's x equals. And these are the same. In fact, let's write that down. Just written in two different ways. This says the word inverse because look again. It says ln of x, not ln of y. Remember, an inverse is when you switch the x and the y. So, e to the x is the inverse of ln of x. Being the natural log. E to the x is the same as ln of y. Okay, so here's something that I need you to think about. The same is true, by the way. The same argument is happening for this stuff right here. So if log is bay, and you have log base b of x equals your function, and exponential is bia, then we should have a base, an exponent, and then an answer. I should have put an x there. It equals x. So notice that these are the same thing. They're just written one in logarithmic and one in exponential. Well, again, pay attention to the details. That's b to the y. That says b to the x. So I'm not contradicting myself. It's all in the details, honestly. These are the same thing. These are the inverses. That's terrible. It's all about what it's connected to, x or y. So when you look, and this is getting really messy, so I'm going to kind of clean up a little bit. When you look at these details, and you've got this proof that I'm trying to show you right now, here's what's really, really interesting. And I need you to notice these and see how easy it is to use them, because we're about to actually use these with real numbers, and it's not that difficult. Everyone always makes it out to be way harder than it actually is. Logs aren't difficult, they're just different. They're very different, and you have to get used to them, which means you're going to have to practice them and actually do your homework. You cannot skirt by on this one. Oops, my bad. So here's the deal. How do I prove this business? Okay, think this through. If log is base answer, exponent, which in this case is a line that we're trying to figure out. Okay, let me go back. I missed something that's important. We're trying to prove that log base b of b to the x equals something, and b to the log base b of x equals something. So we're trying to prove this whole inverse business. I don't know what just happened. That's what I want. Okay. All right. From Unit 2, and I know it's been a long time, we did composition of functions. F of g of x and g of f of x. You maybe remember that we called it FOG and GOF. Okay? When you proved that two functions were each other's inverses, you did composition of functions. You put g of x into f, or you put f of x into g, and you proved that they were inverses when both of them ended up giving you just plain x when it was left over. So what we're going to do to prove that these actually are inverses, which is what we're talking about up here, and I know it's really messy, and I apologize for that. What we're going to do is we're going to do composition of functions, and we're going to see that they both give you x. So here's what has happened. I need some space. Okay. Good. So we're going to take, I'm going to need to make this a little bit different. We're going to take one function and we're going to put it into the other. So if I take f of x and I put it into g, well, g of x says log base b of x. And in the x spot is where I'm going to put in the f function, b to the x. See? That's a b. That looks terrible. I'm sorry. I'm just putting this here, and that is proving that they're inverses by using composition of functions. So the question is, how do I know that's going to equal x? Because that's what the goal is, to make sure it equals x to prove inverses. Okay, well, now we're going to think it through. Log is base, answer, exponent. Exponential is bia. A base to an exponent equals an answer. So the base, using this information, the base is b. The exponent, using this information, is a blank. So b to the what equals the answer. Using this information, there's the answer. B to the x. Okay. B to the blank equals b to the x. What does this blank have to be? X. It has to be x. B to the x equals b to the x. It's the only option. So you just proved that when you did composition of functions for this f or g of f of x, it did indeed give you x. All right, now let's do the reverse. When you're doing f of g of x, this time we're going to take g of x, and we're going to put it into the x spot of f of x. That's where this just came from, because f of x is b to the what? To the x. And we're plugging in log base b of x into that spot. And that's going to equal blank. Now, the goal is to prove that that equals x. Let's see if we're right. This time, because you have a base that's a big base that you're seeing, and you don't see the word logarithm leading the way, you must be in BIA format. You must be in exponential. So we're going to convert from exponential to logarithmic form, and we're going to notice that it has to be an x. Okay, So our base is b, our exponent is all of that, and our answer is a line, an empty box. So then if log is b, when I put the base down, that base is b, of the answer in that spot right there, well, the answer is the empty box, and that's supposed to equal the exponent right there. The exponent is log base b of x. So if the left side equals the right side, log base b of blank equals log base b of x. Logically speaking, it has to be an x. Okay, if you've hung on to that, I'm actually really impressed because that's really tough. Here's the good news. Using that information, using that proof, is actually really simple. So if you have not been able to understand so far, hang on tight, you can do this.